Hello, this is a presentation on using the independent t-test when you want to compare the scores of two groups. I'm Reginald York, professor in the School of Social Work, University of North Carolina, Wilmington. At the end of this presentation, you will be able to employ the York Excel file for calculating the independent t-test for comparing the scores of two groups on an interval variable. That is to say, a variable measured at the interval level. You will know how to use this file to determine the value of both t and p, which will help you determine statistical significance. You will know how to use this file to determine the effect size, which is an aid in determining practical significance. Statistical significance has to do with chance. Practical significance is a matter of opinion, and that opinion has to do with whether you believe the difference between the groups is noteworthy. So I'm making the assumptions you have data for two groups of people on a variable that is measured at the interval level, maybe depression scores, anxiety scores, grades in school, or whatever, and you have it for two different groups of people. You wish to know if the scores of the two groups are different. Is the mean age for all boys different from the mean, is the mean grade for the boys in your school different from the mean grade for the girls? That's one example. Also, I'm assuming you understand the value of p in statistics and basic statistical concepts. Here's an example. You collected depression scores for 17 clients before and after treatment and computed a gain score for each client. You also measured a group of people on the waiting list for your service at the same points in time and computed a gain score for each of the persons in this comparison group. So you have a group of clients and you have a group of people in the comparison group. The comparison group did not get your service. The clients did get your service. You're trying to decide whether service makes a difference. Is there more improvement in depression scores for clients than for those in the comparison group, which in this particular example are those people on the waiting list for service? So you have a gain score for each person on depression for each of these two groups. You now have two variables, gain scores, in group. Here is an example of some hypothetical data. Person number 1 is in the treatment group and score is 23. Person number 2 is in the comparison group. They have a score of 17, and so forth. This is just an example. What the t-test does, the t-distribution is a little different from the normal distribution. It is used where the sample size is small and population standard deviation is unknown. Thus, it is very useful for human service evaluation studies, which is a major focus of a series of presentations that I am doing. It tells whether the mean scores are significantly different. Let's talk briefly about statistical significance and practical significance. Statistical significance tells us how likely our data would occur by chance. Things happen by chance. If all you have is chance, you don't have something you can depend upon. You don't know if the difference between two groups is really different if you were to do the study again, if chance is a major explanation for your study. Statistical significance tells us all about chance, whether your data would likely occur by chance. Practical significance is an opinion about the extent that the data is noteworthy. If it's a 20% difference, is that noteworthy or not? That's a matter of opinion. It's difficult to have practical significance in the absence of statistical significance, given the basic meaning of failing to find statistical significance. If what you have concluded when you examined statistical significance was you can't rule out chance, then how can you say that you have practical significance? Effect size helps with practical significance. The effect size is a score that represents differences in scores measured in regard to standard deviations. The greater the effect size, the greater is the difference. An effect size of 1.0 means there is a 1 standard deviation difference. An effect size of 0.5 means there is a half of a standard deviation difference. Looking at an example, the mean IQ score is 100 and the standard deviation is 15. So if your IQ is 115, you are one standard deviation above the average for IQ. If your IQ is 107.5, I guess you'd be one half of a standard deviation. Effect sizes of 0.3 are considered low, 0.5 is considered medium, and 0.8 is considered large. That, of course, is a matter of opinion. Effect size for independent t-test. The formula for calculating the effect size for the independent t-test is the difference between the mean for the primary scores of the first group and the mean for the other group divided by the standard deviation of the primary group scores. So you may have your client group as your primary group. What is the difference in mean score between the client group and the comparison group divided by the standard deviation of the client group? That's how it's actually calculated. This shows how many standard deviations of difference there are between the two groups. Okay, now I'm going to move to the Excel file, which you can use to actually use the independent samples t-test. And here we go. This is the independent samples t-test. As you can see at the top, it's got the label York Independent T-Test comparing two groups interval variables. This, by the way, at the top is the name of the actual file, Excel file. I'm of course using Excel, so you must have Excel on your computer. You must first load Excel, then load this file, and you're ready to go. I want you to hit the pause button and use a couple of moments to read the instructions. Then I'm going to talk about them briefly. Look at the basic instructions about how you do this thing. Okay, I assume you have stopped and read these things. So what you have is you have the comparing two different groups. Here is your treatment scores right there, starting right here. A11, A12, A13, and so forth. The comparison group over here, that's what you do. You indicate the gain scores. Or if you're not doing that, if you're just comparing two groups, group 1, group 2, what is the value, what is the score for the first person in the group in the first group right here, the second person right here, third person right here, and so forth. The other group, first person here, second, third, fourth. Then what you do is here you will find the mean of the first group, the treatment. I'm using the example of treatment group and comparison group. Here is the mean for the treatment group. Here is the mean for the comparison group. So you'll see which group had a better, or had a higher score. Here then you'll find the value of t. Most importantly, right here, the value of p. This is, by the way, the one-tailed p-value. That means you have a directional hypothesis, which you would have in most evaluation studies. That's why I'm using the one-tailed t-test. If that's not true for you, then you have to look at another way to determine what the value of p is. Here is the value of the effect size for you. We'll determine then, of course, how many standard deviations of difference there is between the two groups. Okay, I hope this will be of help to you in your work.